The purpose of the project. This report aims at describing an external piping system of a residential house that holds 5 people. The goal is to provide a sustainable water supply system that can provide enough water to the consumers every day at an inexpensive cost with quality water that meets standard issuance. The scope of the project. The scope of this project was at Taman Semarak Bukit Tunggal Kuala Terengganu. Additionally, there was Bukit Losong, one water treatment plant who become the main source of water supply at home as well as for residential areas. External piping system. An external piping system is a technique that involves installing pipes on the outer part of a building to transport water from a main source like municipal water supply or borehole to various points, including food chain, plant watering system, and the main water supply point. It has a master line, branches with flow control, pressure reducing station, and blade flow preventers. Common pipe material include PVC, HDPE, or copper pipe, ensuring proper and efficient water supply to the house.
The next part is literature review. For the economic variable, water demand in this category is influenced by a variety of factors, some of which are income and price. According to the economy research, the cost of the water itself is one of the key factors in explaining how much is used. For a climate factor, water demand is higher in the summer because internal demand stays constant, but external consumption rises as a result of the summer month. Temporary climate factors have little effect on internal consumption, but they have a significant impact on outward usage due to environmental factors. For a physical characteristic, residential water demand has been shown to be influenced by housing factors. Several characteristics of the property include this kind: number of bedrooms, size, and presence of garden or outdoor space, as well as landscaping, the availability of a pool, and the house age. The next one is type of water demand. The need for water is growing perhaps as a result of the growing global population. The supply of raw water and infrastructure both place a restriction on the usable portion of the demand. The first type of demand is domestic demand. Water resource provided for human use, also referred to as exterior or domestic use. Both residential and non-residential user authorized use make up the total amount of water consumed. Domestic use include activities like cooking, drinking, washing clothes and equipment, and taking bath. The next part is industrial demand. There are numerous applications for it in the water sector. In addition to being used for many other things, it can be mixed with concrete, washed, and added to goods like food and drink. Water used for mining, hydropower production, energy generating, fabrication, processing, washing, and cooling are all considered forms of industrial water usage. For our industrial demand, we can split into four categories, which is the need for cool water is often removed straight from the river or estuary and replenished with a small loss. The second category is major industrial demand, such as that of paper manufacturing, chemical production, iron and steel production, and oil refineries uses more than 1,000 meter cube per day. The third category is a huge industry is required if the factory is to process food, wash vegetables, make drinks, and produce chemicals, all of which require 1,000 to 500 meter cube per day for space. The last category is the need for medium-sized to small-sized company, which include factory and all other kinds of small manufacturer that use less than 50 meter cube per day of water, primar- primarily from public resource. The last demand is public demand. Water from public water supplies is used by homes, business, and industry to power thermoelectric power plants that are used for everyday purpose. In addition, it is occasionally supplied from irrigation and mining. The public or private water system that survey at least 25 people or has at least 15 service connection is referred to as a public water supply. A public water supply system, for instance, includes systems that serve water to cities, military installation, apartment building, and housing development.
Hello, my name is Hua, and today I'm going to present about the Chapter 3 method of design. So, for our case study, which is the Bukit Losong 1 water treatment plant was located 8.1 km from Taman Semarang Bukit Tunggal, which is our case study area that become the main source of the water supply at home as well as the residential area. This is a table of the water demand for the Taman Semarang Bukit Tunggal Kuala Terengganu, which is our study area. The total IPCD that we have obtained, which is 322,576.8. Next is the design flow of the water treatment plant that we have achieved of 784.03 for the design flow of a water treatment plant at the Taman Semarang Bukit Tunggal. So for the maximum daily demand, as you can see here, the total max daily demand that we have obtained, which is 1411.25 for the Taman Semarang Bukit Tunggal area. Peak hour demand, as you can see here, that we have obtained from our case study area, which is 2116.88 for the total peak hour demand. So next is the fire flow demand. As you can see here from the table, as we have obtained the value of the total fire flow demand, which is 2.27 by using the formula as stated in the table also, as you can see in this slide. So here is the location of the Taman Semarang Bukit Tunggal of the pipeline from the water treatment at the Bukit Losong 1. So for the hydraulic design, in this slide, we have obtained the concept of the hydraulic design, which is stated in this slide. We shown the formula of the hydraulic design and so on. At the part D, also state that the pipe size of the HDPE is 250 millimeter at the peak demand of the condition for the single story, which is 7.62 meter, and for the double story, which is 10.67 meter, and the peak factor for the domestic draw off should be around 1.8 average flow. So here are the three tables from the ePanet, the result that we have simulate using ePanet web, as you can see here in this slide. For this table is showing the flow, velocity, unit head loss, friction factor, and status for the simulation from the ePanet website. And here's the table to show the value for this presentation slide. Next is showing the pressure versus velocity distribution. As you can see here, the color that we achieve is green and blue, which is safe and suitable and is okay also. For the demand versus flow distribution, as you can see in this figure, it's shown that it's in the suitable area. I mean, it's okay situation. As you can see the line at the top left here, as you can see in this slide, which state the danger to safe level or safe to dangerous level. So the next is the top water level located at the Taman Semarang Bukit Tunggal Kuala Terengganu. As you can see here is the photo of it. So the top water level that was suggested at 45 meter, the value of the suggestion is from the neighborhood of the case study area.
Assalamualaikum. My name is Nisa. So as a conclusion, from the EpiNet apps was used, our project found out that there were 55 pipes in the external piping system at Taman Semarak Bukit Tunggal, Kuala Terengganu. So the range of flow rate in the network is from negative 0.15 liter per second to 11.76 liter per second. There were 33 pipes of 50 There were 33 pipes out of 55 pipes have a greater flow rate than 0.3 liter per second, which is have higher than minimum flow rate. So the entire demand during peak hour for the whole system in at Taman Semarak Bukit Tunggal Kuala Terengganu is 2,116.88 meter per minute.
I am Nur Amira Ajagla Zulkifli. I will present the last part, conclusion and recommendation. For the conclusion of the project, to guarantee the effective and uninterrupted water flow, the system needs to be designed with all supply lines, valve and meter, and solidly built and installed. We also prioritize the reliability and ensure the efficiency of the system for long term. We also by maintaining the consistency of the water pressure, providing a steady and reliable flow to all parts of residents regarding the calculation that already has been made. For the recommendation, we recommend by adding a leak detection system. The system actually will minimize the potential damage and also ensure early identification of the issue. We also recommend by using high quality materials like durable materials such as PVC, copper or PX. Also combined with protective measures against the environmental factor and enhance the system as well. Lastly, a well-designed external piping system is crucial for a reliable and efficient residential water supply. That's all. Thank you.